All right. In Lesson 8.1, problem number 5, we're going to look at a couple application problems. And the application problems that we're going to look at is the falling object model, which will follow some kind of quadratic function. Okay? So what that means is the graph is going to be a part of a parabola. Okay? So whenever I graph it, it's going to be a U-shaped curve either pointing up or down. Now if it's a falling object, okay, just like in our homework, it should be half of a curve that's pointing down, right? So let's look at this problem 5a. An acorn drops from a tree branch 20 feet above the ground. The function h equals negative 16t squared plus 20 gives the height h. So the height is going to be the variable h, okay, of the acorn in feet after t seconds. So the time is t, but it's referred to in seconds. And this height h is in the units of feet, okay, on our graph, and also in our function. So the height, the output, is referring to the feet, okay, after so many seconds. And then the t is referring to the time that's dropping. So it says, what's the graph of this function? So we have to graph this function. At what time does the acorn hit the ground? Now there's two ways of coming up with a table in order to graph it. There's the old-fashioned way in which we input, varying times. Like after 0 seconds, a half of a second, 1 second, 1.5, 2, and so forth. We can enter a lot of different values. So we'll do a couple the old school way, and then I'll show you how to come up with a table that might be easier for some of us that have difficulty doing the math. Okay? So first of all, if my time, t, was 0 seconds, input that into your function rule. So this would be negative 16 times 0 squared plus 20. And so negative 16 times 0 squared means 0 times 0, which would be what? 0. Negative 16 times 0 would be 0 plus 20 is 20. So what that means is that if my time, here's my time, my x-axis is my time, is 0, my height of the acorn was 20 feet. So that is a point on the graph. These are ordered pairs. If you input a 0, my output was a 20, and inputs are always your independent variables, which are your x's. Your outputs are your dependent variables, which are always your y's. Y'all follow that? Okay, let's do another one. Which one looks easy to calculate with pencil and paper? The 1/2 or the 1? So let's do the 1 with pencil and paper. And then I'll show you how to come up with this table if we were not using pencil and paper. So this would be negative 16 times the time squared plus 20, and the time here is 1 second. So after 1 second, how high is the acorn above the ground after dropping? So this 0 means initially you start off at 20 feet. Then after 1 second, how high above the ground is the acorn? Or did it already hit the ground? That's what we want to look at. So let's plug it in. Negative 16 times 1 squared, and 1 times 1 is 1, so that's negative 16 times 1, which is negative 16 plus 20. What would that give me? Negative 16 plus 20 is 4. So after 1 second, I'm 4 feet, and I'm counting by intervals of 2. Can y'all see that? 2, 4, 6, 8, 10. So after 1 second, I am 4 feet above the ground, so put a dot there. Okay? And then we can find other points on this table. And we could do this with pencil and paper. But remember what I said? I said I'm going to show you an easier way of coming up with this table, so that way I'm not good at the math. I can come up with my inputs and outputs a little easier. So an easier way of doing this is to take that function rule and plug it into your calculator. So how do I plug that function rule into my calculator? Do y'all remember that from the other day? You cut it on, and then I'm going to do what with it? Graph it. So I've got to go to a new document. So I go to my home screen, go to new, which is 1. All right, since I'm doing a new document, I do not want to save my last one, so I go to no. And then add your graph, which is 2. So that's where I put my function rule. Now notice it's not an h, but it's an f of x. Right? That's my output, in other words, is a function rule. So what is the function rule? To get the output of the function, it would be negative 16 times t squared. Now, once again, in my calculator, I don't use the same letters that they use in the function rule, so I have to use the variable that is my independent variable, which is my x-axis for t. So my output depends upon the input, so that's my x's, so that way I can graph it on the x-axis. So that would be an x. So my x is down here at the very bottom of my calculator is where I'm getting that x. Okay, and then I'm going to square that. And then add 20. Everybody got the function rule put in there? And then when I hit enter, I see that table, right or wrong. Hit enter. I don't see the table. What do I see? I see the graph. Except I see the left side and the right side of the graph, and I see the bottom of the graph. Right? Don't worry about that. How do I come up with the table? Yeah, just go to the table. So I can get to the table by going to menu and going over here to table, which is 7. And then I could go to a split screen table, which is 1. That's one way of coming up with the table. All right, and in order to remove the table, I could go to menu and remove it that way as well. Or I could just hit Control T. Watch. Hit Control T, and that removes my table, but also it would add a table by hitting Control T as in Tom. See the tables there? Y'all see that? There's two different ways of coming up with that table. We good? Okay, so let's check our values. If my input was a 0, what is my output? 20. Do y'all see that? Any questions there? All right, so what if my input was a 1? Did I do the math right? My output should be a 4. What if my input's a 2? What's my output? Negative 44. So I don't have to do that math there. It did it for me, so fill in your blank, negative 44. And we did that in the calculator. So you could just say we did it in the calculator there. But what about this 1/2? I don't see this 1/2 here. Do y'all see 1/2 there? How do I get it to input my own values, like if I wanted to input a 1/2 or a 3/4 of a second or 1.5 seconds and so forth? Okay, so let's find this 1/2 point. If it's 1/2, here's what we're going to do. Okay, I want to go to menu. Hit menu real quick and then go to table. So once my table is up, just hit menu, go to table. Click over to the right here or hit 2. Okay, and then we want to go to edit table settings. So that way I can input my own values. So go to 5. Okay, now you see where this table starts? It's starting at 0. So tab over. This table step means that it's counting by ones. So it's going from 0 to 1. So it's like this: 0 to 1 to 2 to 3 to 4. And it could also go to a -1, -2, -3. That's what it's saying about it. You're counting by units of 1. Okay, I'm not even going to worry about that. I want to tab over to where it says your independent variable. See how that says it's automatically going to produce them? I don't want it to automatically come up with a table. So I'm going to change that auto for my independent variables, which means my input values, my x's in other words. Remember that? The x's of the independent variables. Change that. So we're going to tab over to change that. So click over to the right once it's highlighted and go to ask. So instead of automatically coming up with it, it's going to ask you for values to plug in yourself. All right? So once that's the ask, leave this as auto. Go to tab, tab, until you get to OK, hit enter. And then come over here and you can enter in whatever you want. We can enter in a 0, just like our table, and then a 1/2. See, now I just changed it to ask me, what do you want to enter? And I'll calculate those values. So I know if x is 0, I'm at 20. 0, 20. If x is 1/2, where am I at? 16, and I did that in my calculator, right? So what if I'm at a 1? Hit 1, enter. See, I'm at a 4? That function is going to be very, very helpful on your EOC. 2, -44. Because you're going to be given input values that you're going to have to plug into some function rule to tell me the output. Or you're going to be given a domain, and you have to find the range. So if you know how to do that, you don't have to do the pencil and paper work here. You can just plug it in your calculator. So you might want to come back to this video and look over it, right, before you take your EOC if you're doing function rules. to find domains and ranges, or a range given a domain might be helpful, or to fill out a table, right? Just like this. So then let's plot these points, if I can. We've got a 0, 20, already got it plotted. What about a 1/2, 16? Here's 1/2, and then I'm at a 16. There's 10, 12, 14, 16. If I wanted to go more, look, what if I wanted to go 3/4 of a second? Well, I can go over here to my table and go 3/4 enter, and then get more accurate points. I'd be at 11. So 3/4 of a second, I'd be at 11. So that way my graph gets a little bit more accurate. What if I'm at 1.2 seconds? Where am I at? Oh, -3. I'd be down below this. If I'm at 1.2, I'd be at a -2, 4, 6. But does that make sense? This acorn is falling out of a tree, is it not? And then what's going to happen to it? It's eventually going to hit the ground. Where is it going to hit the ground? Did it hit the ground after 1 second? No, it's going to hit the ground just barely to the right of 1 second. But where is that? Where is this point right here to where it hits the ground? See, I could sit here and guess. Let's try guessing values. 1.1. Oh, didn't hit the ground yet. It's 0.64 feet above it. So I have to guess in between 1.1 and 1.2. So maybe it's 1.05. Nope, that's 2.3, right? So I'd have to guess in between those and so forth. Actually, that was a bad guess. It should be 1.15. I'm sorry. It's still negative. I don't know. So I'd have to guess in between 1.15 and what? 1.1. So I'd have to keep guessing and checking in between values until I get it. But I don't have to do that. Where this hits right there is called the x-intercept. Isn't it? That is where y is equal to 0. So what I could do is I could just plug in my y, which is 0, into my function rule. And my y is referring to my height, which is 0. So I could just say, hey, if the height is 0, if this height is 0, what would x be? So I can plug in the output to the function to find the time that it hits it. I could do this with pencil and paper. You see what I did? Plug in a 0 for the height and see what is the x that returns a 0. This is day 1 in Algebra 1. Day 1 in Algebra 1, we learned how to solve equations. How would you solve this equation for t? To get the t by itself, what would you do? Step 1, distribute. Remember that? Nothing to distribute. Step 2, combine like terms on the right side of the equal to the left side of the equal to. No like terms to combine. Step 3, get the letters on one side, numbers on the other. Variables on one side, constants on the other. Look, there's a constant right here. I got to get over here to this side. How do I get this over here? I can pick it up and move it, and it becomes a -20, right? Same thing as subtracting 20 from each side. Now, is my variable by itself? My last step is to isolate the variable. What's attached to that variable or that letter? A 16. How is it attached? So how do you undo it? We divide. So t squared is equal to, what's negative divided by negative? It would be a positive, and 20 divided by 16 is, just reduce it. It's a fraction, isn't it? What number will go to 20 that will also go to 16? 4. Divide this by 4, it would be? 5. Divide this by 4, it would be? 4. 20 divided by 4 is 5. 16 divided by 4 is 4. So is the t by itself yet? Nope. What's wrong with it? It's got a squared on it. Right? I don't want to know t squared. This means if I were to take my time and multiply it by itself, it gives me 5/4. But what is just t? How do I get t by itself? So how do I undo a squared? From chapter 5, I use a square root. So you got to remember all of chapter 5 as well. So the square root undoes the square, because what two numbers can you multiply together to give you t squared? It's t. And then take the square root of this. So my answer is the square root of 5/4. And what is that about equal to? That's where it hits the ground. That's where the height is 0. Where is that? Not as a fraction, not as a radical, but as a decimal. So let's take the square root of 5/4. So hit Control, square root, 5 divided by 4. And then hit Control, Enter. What'd y'all get? It's about 1.118 seconds if we rounded it to 3 decimal places. The tenths, hundredths, thousandths place. The 8 tells, or the 0 tells the 8 to stay the same. So it takes about that many seconds for it to hit the ground. So we can answer the question now. Okay? So what's the graph of this function? There's a graph of this function. Where did that point right there hit the ground? Where is that exact location? It is at 1.180 roughly, or the square root of 5 fourths 0. Same thing. The square root of 5 fourths comma 0. That's my x and that's my y coordinate. So we can answer the question, when's it going to hit the ground? When's the height 0? The height 0 at what? 1.118. Do y'all see that? Seconds. Now, is that kind of hard to do? Really? We already said this. We said that this is the x-intercept. This is where y is equal to 0. But do y'all know another word for the x-intercept, or where y is 0? What's another word for that, where a graph crosses the x-axis? It's called the 0 of a function. You know, your calculator will tell you the 0 of that function that you already put in there. Watch this. Let's cut on your calculator. Go back to that. Go back to that graph. How do I go back to the graph? Go to your home page. Go to your current document that's open. So that's 4. So hit home 4. And let's find out where that crosses the x-axis right there. So let's take the graph off so we can see this bigger. How do I take the table off? I'm sorry. How do you take the table off? Control T. See it a little bit bigger now? Now find out that x-intercept. All your calculations in this calculator are found under menu. So hit menu. Okay? Now we've got to find out the x-intercept, so we have to analyze the graph. So go to number 6. We'll analyze it and find different things for it. So let's go to 6. And in 6, in this graph, I want to find the x-intercept. I see nowhere where it says x-intercept. But another word for x-intercept is where y is 0. Where y is 0 is called a 0 of a function. So we can find the 0 of this function. Now once I hit 0 of that function, I've got this little line. I need to move this little line to one side, and I usually always take it to the left of where I think the 0 is. And I wouldn't take it over here. Why don't I take it over here? Because negatives don't make sense in this problem. Where did the acorn drop? Not in negative time. The negative parts of this graph doesn't make sense. When time was 0, this acorn was 20 feet above the ground. I don't want to know when time was negative 2 seconds in the past. No. Okay, I want to know initially when the acorn initially dropped. So the graph only makes sense from here down to the ground, from its highest point to its lowest point. So don't find that 0. Find this 0 to the right of the origin. So you move that little dashed line to the left of where you think it is, and hit the middle of your screen for enter, and then move it to the right, and it say, hey, I want to find the 0 between those two lines. And it'll pick it up for you, and it's right there. How is that any different than what we got right here? Isn't that the same value? 1.118034? 1.1180, we had 34 something when we went to the calculator and found the square root of that 5 fourths, right? Isn't that really the same thing, except it rounded it to this decimal place? You got it? That's the same thing we got there. So which way is easier, to get your calculator to find the 0 or to do this right here, calculate it with pencil and paper? What do y'all think? It's up to you. You could have that choice. So we answered the question. Now the second part of the question says, tell me a reasonable domain and range of this function. That's part B. What's a reasonable domain and a range for this function? Well, remember, domain is talking about the x's on the graph. Your x's from left to right. So that means what is the lowest time in seconds to the highest time in seconds. Okay? Now, these can't be negative. Okay? Why? Why can't they be negative? Because we're not going back in time. We're looking for when we initially let go, start the timer until it hits the ground. Right? And also, the time cannot be larger than what? What can the time not be larger than? It can't be larger than when it hits the ground. Because once it hits the ground, the time stops. So here's what happens. As soon as you let go of the acorn, it's falling, 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 time's ticking, right? Then all of a sudden time stops as soon as you hit the ground. So it's like a stopwatch. I start it when it starts falling, I stop it whenever it hits. So what is the lowest amount of time? What's the highest amount of time? So really, what are the X's in between my fingers? It starts at 0 and hits at 1.18. So it cannot be longer than the 1.118 seconds. And it can't be negative, so what are the X's on this graph that makes sense? Or what is the time that makes sense? My time should be greater than or equal to 0 if it can't be negative, and it cannot be any larger than 1.118. You understand? Any questions about that? So it's like this also. What about the range? That's the height of the acorn. The acorn was never higher than 20, and it never hits below 0. A height of 0 feet above the ground. Why? Because the acorn doesn't hit the ground and continue to go through the ground all the way through the earth, right? Once it hits the ground, it's going to stop at 20 feet. So can anybody think about that? Here's what the thinking that it should be. It should be you can't be negative because negative shows that it's penetrating the ground and going through the ground. So it must be bigger than 0. And the height can't be higher than where it fell from. So what can it be higher than? The highest it can be is 20 feet. And so if it can't be negative, the lowest it can be is 0. So my height has got to be in between 0 and 20. So my height has got to be greater than or equal to 0. It can be equal to 0 though, right? Because once it hits the ground, it's 0. And it's got to be smaller than, less than, or equal to the 20. So that's how we do domain and range of those. Are we good with that? All right, let's go to our last problem. We'll do this one a little quicker because this is the same problem. So this one we're going to do in our calculator to speed it up. I'll show you all calculator calculations. I've already shown you how to do it pencil and paper, so how would we do this in a calculator? Same type of problem. An acorn falls out of a tree. This time it falls out 70 feet above the ground, so here's the height. This is 10, 20, 30, 40, 50, 60, 70, so it's here. When time is 0. That's where the acorn is. And it's going to fall out and drop. Where's it going to hit the ground? Let's figure that out. Where's it going to hit the ground? Let's just plug in our calculator and see. So we're going to take that function rule. Same problem, plug it into our calculator. So go to your home screen. New document. Don't save your last one. Add the graph. Everybody there? So that's 2. Plug that function rule in. Negative 16x squared, because I don't have a t in my calculator, plus 70. Hit enter. You want to see a better picture of it, like ours? Let's set up this menu, this scale, to look like this, okay? So I'm going to teach you something else on your calculator. So we want it to look like this. Or close to that. Go to menu. Let's change our window. Let's go to 4. Go to window settings, which is 1. Let's change our minimum to be a little bit to the left. See, this is my axis, my minimum axis. See, I've got 0 to 4. Let's just go to the left a little bit of 0. Let's go negative 2. And let's go to, I don't know, we can go 4 seconds. Now, what are we counting by here? Look, what am I counting by here? A half, 1, 1.5, 2, 2.5, 3. So they're counting by, that's your scale. 1/2, which is the same thing as 0.5. So we want to get it to look like that so we can get our scale to count like this. Look at my y's. I'm counting by 5s. So that y scale is going to be a 5. So that way it can look like this. Okay, but what's a y minimum? Let's go a little bit below here, 0, so we can see the x-axis. So tab over to a y minimum of negative 2 like we did here. So I'm going to go from negative 2 all the way up to, let's go to 70. Actually, let's go a little bit above 70. Let's go to an 80. Tab. So my y max would be an 80. Tab. And what are we going to count by? What am I counting by here in my picture? 5, 10, 15, 20. So that's counting by 5s. That's your scale, was what you're counting by. You good with that? Got it entered? Go to tab. Okay. Looks kind of like that, right? little bit better, except it's going over here to a -2, just a little further. So this is including a -2 here, right, wherever. So there's my -2, there's my -1. And it goes down a little bit below this too. So that's what my graph's going to look like. It's going to start at 70, and where's it going to hit the ground? Look, there's a half, there's 1, 1.5, 2. It's over here a little bit past 2. Where is that? Can y'all tell me where that hits that axis? What's that called, where it hits the axis, or where it hits the ground? It starts at 70. We know that. Where does it hit the ground? Go to Menu. Where do I go now? Y'all tell me what to do. How do I find the x-intercept? Analyze graph. All those features of graphs are there. That's number 6. And then I go to x-intercept. I don't see it there. What's the same thing as an x-intercept? What's another word for that? It's a 0. Move that to the left of where you think it crosses it, enter, and then to the right of where you think it crosses it. It even says, hey, here's the 0. Where is it? Where does it hit it? Just barely to the right of 2, which is at what location? 2.091650 0. So what does that mean? After this many seconds, it is 0 feet above the ground, which means it hits it. So if I have a smooth little curve from here to here, boom. Should I graph the left side too, like they did? Do I need to do the left side like them? Why not? It doesn't make sense as it relates to the problem. Why doesn't it make sense? And why didn't I go down below this? So why didn't I graph this, first of all, to the left? The x's that are negative. Because that represents what? Negative time. Right? We don't have a magic time machine where we can go back in the past. Why didn't I go down here? Because it's not penetrating the ground. It's just going to hit the ground and maybe bounce and stay there. And plus, it's just started right here in the tree, and really the left side would look like this if we did this in time. It would be hanging in the little tree branch, and it's like this. That's really what it looks like to the left of it. It'd be a straight line. It's still there. The height is there as time is ticking. All of a sudden, a wind blew, boop, it fell off, and then we start counting, and then it hit the ground, right? So that's really what it looks like. The left side of the curve wouldn't look like that. But the right side looks like a parabolic curve, right? Okay, so we could fill out our table. Let's fill out our table real quick to find other points. How do I get to those other points? Control what? Control T, but the problem by going to Control T is that these are only counting by whole number of units. Look at this. This is counting by halves, right? There's 0, 1/2, 1. I could do 1.5, 2, 2.5. You got that? So look, let me show you another way of changing the table to where I can count by the same scale, to where I don't have to go ask. I can automatically come up with halves in there. So instead of going by 1, 2s, 3s, and 4s, watch this. Hit Menu. Go to Table. Go to Edit Table Settings, just like we did a while ago. All right. Table start at 0. Tab through that. Table step. Oh, there we go. We're going to change that. The table step is like our table was counting by 1, 2, 3, 4. So now I want to count by not ones, but I want to count by halves. Put a 0.5 there. Leave this as auto. Leave this as auto. Watch this. And then go to OK. Look at my table. It's counting by halves now. Look. 1/2, 1, 1.5, 2, 2.5, 3, 3.5. So how did I do that? I'll show you one more time real quick how I did that. We go to Menu, Table, Edit Table Settings. All right, and then our table starts at 1. We're going to start that table wherever you want. You can start it at a -1 if you want. I can go back up here and start it at a, and go back up, -1 if you want. And then we're counting by 0.5. So change that table step to a 0.5. Leave it auto, so it'll do it automatically. So tab over, and just go to OK. See how I started at a -1? Okay. And then fill out our table. If I'm at 0, where am I at? 70, and that's our calculator, so we're not going to put anything there. We're not going to show the math there. 0.5 would be at a 66. 1 would be at a 54. 1.5, don't want. 2 would be at a 6. 2.5, so if you wanted to add 1, 2.5 would be at a -30, which that doesn't make sense. Okay? And then we could plot those points. If I was at a 0.5, I should be at a 66 somewhere. Right? If I was at a 1, I should be at a 54 if I did this right. So it's not a very pretty picture because my scale's not like perfect like graph paper is. If I use graph paper, it'd be more accurate. And then if I'm at a 2, I'm at a 6. Right? So once again, it's not perfect because my graph paper is not used. But I get the idea. So answer the question, when will the acorn hit the ground? And let's round it to 3 decimal places. And this means approximately how many seconds? 2.09. I'm rounding it to 3 decimal places, so should that be a 1 or a 2? 2 seconds. Very good. Last question, what's a reasonable domain for that function? What are the x's? The x's are referring to my time. So my time should be in between what values? 0, right? Because it doesn't make sense to have negative time. And so my time is my x's. So my x's are in between 0 and 2.092 seconds. Why? Because I don't have negative time. And then the time stops when the acorn hits the ground. What's my range or the height of the acorn? The y values, in other words, should be from the highest it is to the lowest the acorn is, just like your time. What's the lowest time? What's the highest time? The range is the biggest y to the lowest y. So can y'all tell me what the height is? The height should be between what values? 0 and 70. Very good. And that's it. Okay? So our homework tonight is to do the Math Excel 8.1, and you should be working on quadratic functions and their graphs, okay, on that Math Excel. Y'all get busy. Y'all got the rest of the class period to do that.